Today we're going to refresh your memory on significant figures. I know you didn't use them in physics, but I'm sure you've missed them a ton. So you've all done sig figs before. We just want to dust off those cobwebs a little bit and see what you remember. So the basic idea behind sig figs is that when you make a measurement, you're always making a guess on the last digit. It's a logical guess, but you don't know what that last digit is for sure. So we don't want to overstate what you know for sure when you're making a measurement. That's basically what sig figs are. So to try and decide if a digit is significant or not, there's 3 rules. The first rule is that any number that's not a 0, so in other words 1 through 9, would be considered significant. Why would you write down that something is 13.27 centimeters long unless you thought it was 13.27 centimeters long? The thing is, though, when you're looking at zeros, there's something weird about the way the human brain works. Pretty much all of us, if you were to measure something that's 19.9999999 centimeters long, we all just say 20. That 0 is rounded. It's not actually 20, but we kind of chop off the 0.999 and go to the closest 0. It's just kind of human nature. But what if the thing that you're measuring is actually 20 centimeters? So the zeros sometimes count and sometimes don't. And so there's 2 rules to help us to decide if a 0 is considered significant or not. The first one is what I call the sandwich rule. If a 0 is sandwiched between 2 significant figures, then that 0 is considered significant. In other words, it's actually really measured, that it isn't a rounded 0. So if you were to look at the 6 different examples of the measurements that you see below, there are 6 different numbers there. So again, anything that's not a 0 counts as being significant. So in this first one, the 8 and the 7 count, and then that 0 is in an 8-7 sandwich. That means that this measurement has 3 significant figures. For the next one, the 1, the 3, the 1, the 2, and the 2 all count. This 0 is in a 2-2 sandwich, so it also counts. The next guy down, this 0 is not in a sandwich because there's nothing to the left of that 0. So that one does not count as a significant figure. It's just a placeholder. In fact, if you dropped this 0 entirely, the number doesn't change at all, right? So it must not really be important and measured. These next 2 zeros they have something on the right side of them for a sandwich, but this 0 we said did not count. And therefore, because it only has something on the right-hand side and not the left, those zeros are not considered significant. They're just placeholders because whatever we're measuring, it's just really, really small. This 8 and this 3 would count, and then this 0 is in between. It's sandwiched between the 8 and the 3, so this guy counts. If we go over here, the 300, this guy counts. The zeros don't have any bread on the right-hand side of their sandwich, and so this guy only has 1 significant figure. This is a case where the measurement was probably 299.99999, and someone rounded to 300. So it's a rough measurement. 1 sig fig, not great. This one, the 2 and the 9 both count, and these zeros are both in a 2-9 sandwich. You can have a Whopper sandwich. You can cram in as many zeros as you want in between 2 significant figures, and all the zeros in between count. So this guy would have 4. This one, the 1 counts, but the 0 next to it does not. There's nothing on the right-hand side of the 0 to complete our sandwich. So this is another 9.99999 situation or a 10.0001 situation, and someone went, it's about 10 meters. So this is another not great measurement. It's been rounded. It only has one significant figure. The other way to decide if a 0 counts or not is what I call the right rule. If a 0 is to the right of the decimal point and to the right of a significant figure, then that 0 is considered significant. It was actually measured, not a ballpark rounded number. So it has to fulfill both requirements. That's why it's called the right rule and not just the right rule. So this first example here, the 1.08, well, honestly, we know that that 0 counts because he's in a 1/8 sandwich, but let's pretend we didn't know the sandwich rule. That 0 is to the right of the decimal point and it's to the right of the number 1. So this 0 would count for both sandwich and right purposes. So this measurement has 3 significant figures. For the next guy down, this 9 counts. The one after that 9, this 0 is to the right of the decimal point and it's also to the right of the number 9. So it counts. The next 0 is to the right of the decimal point. It doesn't have to be immediately to the right, it's just somewhere to the right. And it's also to the right of the 9 and the 0, so it counts. And for the same reason, so does this one. He's also to the right of the decimal, just anywhere to the right of the decimal, anywhere to the right of significant figures. So this one has 4 sig figs. So this measurement isn't just ballpark 9, this one is 9, all the way out to the 1,000th place. You're pretty sure that measurement. This next guy, the first 0 right here, this guy is not in a sandwich. There's nothing on the left-hand side of the 0. So it can't be a sandwich 0. It's also to the left of the decimal point. So he can't follow the right rule. So this 0 does not count. The next 0, just behind the decimal point, that one can't be in a sandwich because there's nothing to the left of that 0. And he only fulfills half of the right requirements. He is to the right of the decimal point, but not to the right of something significant. So he does not count. Neither does he, and neither does he for the same reason. They're only fulfilling half of the right rule. The 4 counts, so this only has 1 significant figure. It's quite frankly a lousy measurement because there's only 1 measured digit. This last one's a little bit tricky. We know the 1 counts because anything 1 through 9 counts. This next 0 might be a significant figure if it's in a sandwich. It can't follow the right rule because it's to the left of the decimal point. So he's a maybe. We have to decide about this 0 right here behind the decimal point. Is he significant or not? Well, he's to the right of the decimal point and he's to the right of the number 1. Again, it's anywhere to the right. It doesn't have to be immediately to the right. So that 0 counts as well. Therefore, this 0 is now in a sandwich. So this guy has 3 sig figs.